third dimensions to figure this out here. So the world we live in is in 3 dimensions. You probably know that. Sometimes time is considered the 4th dimension. The distance between 2 points, there is a formula for that. The midpoint, though, is probably the easier one. So the midpoint is it's always the average. So like you take -3 and -8, you add them up. Okay. You add them up and divide by 2. Then you take the next point, 0 plus -9, and you divide by 2. And then you take the -7 and the -11 and you divide by 2. So it ends up being -5.5, -4.5, and -9 for your midpoint. Is that okay?
Yes.
Right. Do you remember at all how to find distance between 2 points?
I think so.
It's okay if you've forgotten, but just let me know. That way we don't waste time on me asking you if you know it or don't know. We can just jump right to the formula here.
Yeah.
So you actually take your second number, -8, and you subtract your first number, and then you square it. And then you repeat for the next number here. So it'd be like -9 minus 0 squared. And then the last one is -11 minus a -7 squared, like this right here. So does this at all remind you of the distance formula for 2 points?
Some of it does. It's
So the distance formula actually stopped after the first 2, but in 3 dimensions, four dimensions, you can just keep going. So again, you get negatives inside here. So this is 25 plus 81 minus a minus. This is plus 49, and you got to take the square root of that. So if you could do that for me, that would be great.
okay.
You got a number for me?
12.4.
I don't think so. So maybe I made a mistake. Yeah, I did. This is 11 minus 11 plus 7. So that's going to be 16 there. So go ahead and change that. And are you using the Desmos Scientific?
No, I'm just using a normal calculator.
I would recommend doing the Desmos Scientific because we're going to be doing a bunch of these calculations, and all you can do, you can just change the numbers each time rather than having to recalculate them. Do you need a link to that Desmos Scientific?
No, I do not. So it's going to be 11.
It is 11, agreed. Okay, so we're going to do another problem that is just like it. There's a lot that are just like this here. So I guess I'll be a little more formal with how I show it because we're going to do it more than once. So the midpoint is the first thing you want to calculate. So these are x1, y1, z1, x, y, z, x2, y2, z2. So to find the midpoint, x1 plus x2 over 2, comma, y1 plus y2 over 2, comma, z1 plus z2 over 2. Basically, you just take the first number, you add them up, divide by 2. second number, add them up, divide by 2, third number, add them up and divide by 2. Can you give me the midpoint here whenever you got it?
Okay. Okay, I get -6, -1/2, and 3/2.
So like this,
Yes.
is that right? You said -1/2 and 3/2.
Yes.
Good. Okay, now if I just snip the points here, I'm gonna do that in the next problem. There's just too many words that go with it. The distance formula, again, it's very algorithmic. Like you can do you just like, if you have that Desmos scientific out, your distance is x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared square rooted. So in your Desmos scientific, you can take that x2 minus 9 minus minus 3. Okay, and remember, it'll do the calculation for you. Like you don't have to do it. So like it'll fill it in. So it's 5 minus a minus 6. It'll subtract, it'll square, plus, and you see where I'm getting the numbers, x1, x2, x3, y1, y2, y3.
Yes.
And then the last one is -4 minus 7 squared, square rooted, like that. And like you could do like we did and like try to figure out what the number is and then square it, or you can let the calculator do this for you.
Okay. Okay, I get oh, whoop. I get 16.7.
Perfect. That's really good. Let me just confirm here your midpoint. You said -6 minus 1/2. Is that right?
Yes.
And then 1.5. Good. Okay. So what do you think you're going to do in the next problem?
Probably the same thing.
The same thing. Yeah. So um, there's actually not a lot of exciting stuff here. So let me have you try this one. Go ahead and work out the midpoint and then the distance formula, please.
Okay. Okay, so I get 2.5, 2, and 6.
Give me just a moment here. You talking about for the midpoint?
Yes,
Give those to me one more time. I'm sorry. 2.5.
2 and 6.
Okay. And then go ahead and find the distance between them, just like
Okay.
we did last round. Now, if you have that Desmos scientific up, you can just start changing the values, and it'll do the calculation for you.
All right. I get 14.6.
Okay. And you said the midpoint again was 2.5.
2 and 6.
Perfect. Okay. So let me have you do, we're gonna do one more, and then this will be the last problem for this lesson. I'm sorry that's so repetitive, but that is, they essentially gave you 6 questions that are exactly the same. So again, just give me the midpoint and then the distance for this last one.
Okay. For the midpoint, I get 4.5, 4, and 6.
Okay, I agree.
And I get 13 as
13
my,
as your distance.
yes.
All right, perfect. Okay, so we're gonna think we're done with this lesson, and we're gonna do a next assignment thing, and we'll see if we can come up with some different problems um, to work on.
All right.
There are 12 questions. Boy, I hope that this assignment is short. It is. Okay. um, all right. So I don't know if you remember what the isometric refers to. Do you have any recollection of that
I
from
think
when
it was top to bottom from side to side.
the isometric's actually just the corner view. It's just it's kind of a 3D view where they like say, okay, there's your ooh, I didn't draw that well.
It
There
looks
it
to
is.
be
There
that
it
there's 5
is.
blocks.
Right. And so they kind of show you this view here like this. I don't know, is this like that? So we'll just go with that. Let's do the next one, which is that, front side top thing. So let me snip it in. I'm sorry, this is disjointed. It's like doing one thing and now we're doing another. Are any of these, is this the correct isometric view over here on the right? Like, does this perfectly represent this thing here?
Yes,
Yes, it
but
does.
from the top to side, no. Well, actually, the front doesn't, but
Front, no.
top,
And
yes. Side, yes. Well, actually, no, never mind.
Could be the size is definitely a no. So um
Well, I think if they flipped it sideways, that would be the right top. But I don't know if they're trying to say, oh, yeah, look it from a different angle.
right. Okay, let's see if let's see what else we got here. Okay, so here's a problem we just looked at to have you do one more. Hopefully this is the last one that we can look at here. So there you go. Same thing as before. Find the distance and the midpoint.
Okay. Okay, I get 7, 5, and 2.5.
Okay, 7, 5, and 2.5. That's good to me. So give me the distance between them.
Okay. Okay, I get 5.7.
Okay, great. So the nice thing is I think we're all done with those types of problems. The next one is another one of these kind of like top, front, top, bottom, front, side type questions here. So this one, they give you this is given, and they give you a couple of options here for this. Let me just grab the ones.
Is it from like top, bottom, or side?
Yeah, so take a look. Do any of these match? Do any of these like
Well, the top one does match.
are you sure?
Yes.
So like why look at the second row here. Which one is wrong out of these?
Well, the bottom is wrong.
Yeah, the bottom is wrong. And so that's why this is the only one that's reasonable there. Okay. Sorry. And I didn't really know how to ask it other than to like say which one is the right one. Okay, so I'm just looking through the list here. Let me see if we missed anything. Got that. We need to do this problem. Okay. All right, a rectangular prism has a base of 18 centimeters by 15. So it's like saying this is 18 and this is 15, and it has a height, okay? And the diagonal, what the diagonal is referring to, and I think this is hard to see, but it's this point up here to this point here. It's this all the way
So that's the
there.
hypotenuse.
It's the hypotenuse though of this triangle right here, which is a 90 degree, that's a 90 degree angle. This leg, though, you get from the hypotenuse of this other triangle. So how do you find this C here? Do you remember that this is a right triangle?
A squared plus B squared equals C squared.
Yeah, so 15 squared plus 18 squared equals C squared. So C equals the square root of 15 squared plus 18 squared. You see that?
Mhm.
That's C.
Yes.
So then that new triangle where we've got the H that we're trying to find, and I guess I should write that, that's 25. And the C, the square root of 15 squared plus 18 squared is here. Do you see that?
Mhm.
So it's the square root of 15 squared plus 18 squared plus H squared equals 25 squared.
I see.
So how do you solve this? Okay, like what does the square do to the square root?
Well, it unsquares the square root of 15 squared plus 18 squared.
Okay. So H squared is equal to 25 squared minus 15 squared minus 18 squared. And then H you get by taking the square root of all that.
Okay.
I know that was a lot of steps, but if you followed it to the end, it works out kind of nice.
Okay, I get 8.7 as my final answer.
8.7.
Yes.
Okay, that sounds pretty good. Yeah, I agree. Okay, we're going to do kind of a similar problem. This time they give you the, well, actually we'll do kind of the same thing, but it's with the diagonal, but it's more symbolic. Okay, so they tell you that the diagonal of a cube. So cube means that all the sides are the same. Like there's that car, something cube, but actually not all the sides are the same. But I guess people think it looks like a cube. You know what I'm talking about?
Oh yeah, those Kias.
Yeah. So this though we'll call it X, X, and X. You follow that?
Mhm.
And the diagonal's here, like this. You follow that?
Mhm.
So they're telling you that's 20. So we got to find this side C here. So how do we find C from this little triangle?
A squared plus B squared equals C squared.
X squared plus X squared, that's your A and your B equals C
Equals C
squared.
squared.
So C equals the square root of 2x squared. So and it's probably good to redraw the triangle, you know, to kind of separate out the stuff that's there's a lot of stuff going on here. So it's again, it's another A squared plus B squared equals C squared. It's the square root
X
of
squared. Oh,
2x squared plus X squared. You could do them in either order, doesn't matter, equals 20 squared. So on the left here, the square undoes the square root.
Mhm.
And so you have 3x squared equals 400. X squared equals, or X, maybe we'll just go to X. X equals the square root of 400 over 3.
11.5 is my final answer.
Good. All right, so the next problem here, I'll help you set it up, but I do want you to try and work it out on your own. I remember you kind of got a good artistic eye here. When you draw a rectangular prism, it's actually better to draw the base and sort of this orientation
Mhm.
rather than something, you know, like a like that. And then you show the height here.
Mhm.
All right. So this, for example, it does not have to be to scale, but it's 7, 6, and 12 maybe.
Okay.
And here's what you have to find. You need to find this right here.
Mhm.
You have to first find this length,
Which we know is C.
which you know is C. Then you use it with this length to find this last one.
Yes.
Okay, so I'm just gonna mute for as much time as you need to figure it out. Hopefully you've been taking some notes. I can scroll up if you need, but give that a try, okay?
Okay. Uh,
How are you doing on this one?
I'm doing good. I think I okay. So I already know the square roots of 7 and 6, and I added those together to get and then square rooted them. I get 9.2 for C.
Okay, so you think C is 9.2.
Yes.
Okay, so you square that, you square the
Okay.
144, you add it together, and then take a square root to find the last part.
Okay. Okay, so I think I have the answer
Go ahead.
of 12.4.
12.4. All right, let me take a look. Sorry, just stand by here. So I got a different number here. Let me just run through this with you. It's instead of 9.2, we're gonna call it 7 squared plus 6 squared
Mhm.
plus 12 squared,
Mm-hmm.
and you're gonna take the square root of that. Can you just do that part for me and tell me what you come up with?
Yes. Okay, I get 15.1.
Yes. All right. Yeah, I'm not sure what else to say. But we got it. We're through it. So we're just got a couple of things left to look at. I think they're going to get easier for you here. I know it's late. Just you're doing great. Just keep trying to focus here for the last little bit. So this question, they want to know what the cross section is. They're basically saying like, what is this red thing? What does it look like if you were to slice through it? And you could think of this as like a stick of butter, and you cut the stick of butter.
Doesn't
What
that, it's a
it
square-ish?
it'd be a square if they were all the same, right? But
It's,
we don't know that. So what's a more general name for it?
I guess, a rectangle
Yes.
or,
Yes, but it's deceptive because we can't see it to know for sure. Okay.
yeah.
All right. So next question here. It says imagine you are folding this thing up. You're folding it up.
It's a rectangle.
Well, it's not a rectangle. This is a rectangle.
Oh, well,
What's the rectangular what?
oh, prism.
Yes. So there's a ton of prisms, but they all start out like this. So here's a triangular prism. So you draw the front face,
Mm,
and then that's your triangular prism. Imagine you have a square. That's the stick of butter. Okay,
hmm.
you follow that?
Yes.
Imagine you have a rectangle. Well, you can do the same thing. You see that? You can
Yes.
also do it with a circle. Okay. These are all prisms because they're a front face extended. See how they're all extended?
Yes.
Cool. Maybe that was the most useful part of the lesson today. Okay. Classify the figure. Let me snip this in. Actually did a article on, well, kind of this. What does this look like to you? I'm not sure if you can see.
This looks like a kite.
Okay, it does because it's kind of cut right through. This is actually, it's 3D though. It's 3D. This is actually a pyramid.
Oh, now I see it.
Uh,
That's an awful way of making it look like a pyramid, in
yeah,
my defense.
yeah, it's not great. But what is the base? What is the base shape here?
BCD.
No, shape. What is it?
Oh, shape. Sorry. A triangle.
Triangular. So this is a triangular pyramid. Okay. Now, what are the vertices?
B, C, and D.
What about
What?
A?
Oh, and also A. I didn't know if you
Think
were
of it as
talking
a
about the
think of it as a
base.
well, it's a sharp point. It's a sharp point.
Oh,
So the edges, edge, edge, edge. Okay. Edge, edge, edge. Do you follow that?
yes.
All right. All right. So sorry, I'm just trying to figure out what the difference is between these. Why are there so many options? It's not that one. Edges. There we go. Okay. So we take care of that. I think we're down to just our last question. Remember that Euler's thing, vertices, edges, and faces.
Yes.
All right. So I want you on your own here. And maybe this would be tough if it's too tough because of the fact that you're looking at a screen. But I was hoping you could tell me the number of vertices,
Mhm.
number of edges, and number of faces. And if you can't, that's okay. I know it's not a great, but this is a hexagon up top. There's 6 here.
So can you remind me if the vertices are like the points?
The
there?
pointy
Okay,
edges.
okay.
They're imagine you don't want somebody to run into it, so you'd have to put a
So there's 12 vertices.
agreed.
Um,
Faces is
this
probably next easiest.
yeah,
You got the
faces
top,
is
you got the top and the bottom, and you got the windows all the way
so
around.
that's 8 faces, and edges.
So there's 6 on the top.
6, 6, and then 6. So then that's 18.
So the formula was the vertices plus the faces equals the edges plus 2.
And that does not equal, minus two. What did you say, +2 or -2?
Well, I think it was plus 2 because the vertices it's 12 plus 8.
That's 20,
20.
and then the edges is 18 plus that +2, that's 20. So does that does that they're the same.
I think that works.
Yes.
All right, one last look through here. All right, I think that is it. So
All right.
well done. Hopefully you got some good information tonight, and I appreciate you scheduling. I'll send you the notes and the screen recording here shortly, and I'll see you next time.
Okay.
Thank you. Have a great night. Bye now.
All right. Bye.